Hello, my name is hsuyeehtike and today I will be explaining how to solve the questions in mid-unit assignment of MHF4U Unit 3. Okay, for so let's start. For question 1, the question is describe what happens to the domain and range of a logarithmic function under a vertical reflection. Support your explanation with diagrams. So for question 1, I let the parent function be f of x, where f of x equals to log x plus 1 base 3. And then I put the values of x and the values of y came out like this, like I have written in this table. And for domain of f of x, we got x greater than or equal to 0 and x belongs to real numbers. And for range of the parent function f of x must be greater than or equal to 0 and f of x belongs to R. This is because the value of log must be greater than or equal to 0. And then I took the coordinates of x and y and drew the graph, and the graph came out like this. This is the graph for f of x is equal to log x plus 1 base 3. So the question asks me to do a logarithmic function under a vertical reflection. So as the parent function undergoes a vertical reflection, the value of a must be negative. So I let the transformed function to be g of x, where g of x is equal to negative log x plus 1 base 3. And then the domain of g of x is such that x greater than or equal to 0 and x belongs to R. And for range of g of x, the value of g of x must be less than or equal to 0, where g of x belongs to real numbers. And I put the value of x and the value of y came out like this, like I have written in this table. And I took these coordinates and drew the graph of g of x equal to negative log x plus 1 base 3. And the graph came out like this. This is the graph for g of x. So this is all for question number 1. So let's move on to question number 2. So for question number 2, the question is describe what happens to the domain and range of a logarithmic function and both a horizontal and a vertical translation. Support your explanation with diagrams. So for question number 2 also, I let the parent function be f of x, where f of x equal to log x base 4. So I put the value of x like this and the value of y came out like this, like I have written in this table. And for domain of f of x, x greater than 0 and x belongs to real number. Okay, and then for range of f of x, we get f of x must be greater than or equal to 0 and f of x belongs to R. So I took these coordinates and drew the graph of f of x, and it came out like this. This is the graph for f of x is equal to log x base 4. And the real question is that the question asks me to do for a logarithmic function and both a horizontal and a vertical translation. So I let the transform function be h of x, where h of x equal to log x minus 2 base 4 plus 3. So By looking at the equation h of x, we get the value of d is equal to 2 and the value of c is equal to 3. So is equal to 2, resulting in horizontal translation 2 units to the right, and the value of c being equal to 3, resulting in vertical translation 3 units upwards. So the domain of h of x, uh, for a domain of h of x, the value of x is greater than 2 and x belongs to R. And for range of h of x, the value of h of x must be greater than or equal to 3 and h of x belongs to R. So I put the value of x in this equation and the value of y came out like this, like I have written in this table. So then I took these coordinates and plotted on the same grid here, and the graph of h of x came out like this. H of x is equal to log x minus 2 base 4 plus 3. So by looking at these two graphs, we can see that the transform function moved 2 units to the right and moved 3 units upwards. It's clear. We can see clearly in this on this grid. So this is all for question number 2. And for question number 3, the question is graph the function f of x is equal to half times log x minus 4. And for A, graph the line y is equal to x on the same grid. And for B, graph the inverse function f inverse of x by reflecting f of x in the line y is equal to x. And for C, determine the domain, range, and equation of the asymptote of f inverse of x, and for D, the determine an equation for f inverse of x. So I have to, according to the question, I have to draw the function of f of x first on the grid. So I put the value of x like this, and the value of y came out like this, like I have written in this table. And so I took these coordinates and plotted them on this grid, and the graph of f of x is equal to half time log x minus 4 came out like this. And for number A, I have to draw a line. 1 is equal to x on the same grid. So I drew 1 is equal to x is this line. And for question B, I have to draw the graph of f inverse of x by reflecting f of x in the line 1 is equal to x. So I drew f inverse of x. So to take for the coordinates of f inverse of x, okay, it came out like this, like I have written in this table. And for domain of f, for question number C, I have to write the domain, range, and equation of the asymptote of f inverse of x. So for domain of f inverse of x, the value of x belongs to R. The value of x can be anything within the real numbers. And the range of f inverse of x is such that f inverse of x greater than 0 and f inverse of x belongs to real number. This is because the value of log is greater than or equal to 0. And for equation of asymptote of f inverse of x, we get y is equal to 0. So basically, it is the x-axis. So the graph, the line of f inverse of x, the curve of f inverse of x never intersect with the x-axis. Okay, for the I have to make an equation for f inverse of x. So I let f inverse of x to be a. So we get f of a is equal to x. So I put a in the function of f. So we get half time log a minus 4 is equal to x. So I add the next step, I add 4 on the right side of the equation. So I get like this, and then I'm trying to solve the equation, and the final answer came out like this. A is equal to 10 to the power 2x plus 8. So A is equal to f inverse of x. So the final answer would be f inverse of x is equal to 10 to the power 2x plus 8. So this is all for now. Thank you very much for your attention.